going to look at G2, which is volume. Now, we kind of talked about it a little bit when we talked about surface area, but we need to understand that volume is talking about the inside. So remember, with surface area, we were taking these little squares that are two-dimensional, and we would line the outside of our shape with these little squares. What we're going to look at today is filling this shape up, which is volume. So we would take these cubes, and pour them in, and we would have to count how many would fill up the base and how many would fill up how tall it would be and in each dimension. So there would be 3 dimensions here, length, width, and height. You would have to figure out how many cubes would go length, how many cubes would be packed in for the width, and how many cubes would be packed in for the height. So this is volume. Volume is 3-dimensional, and it takes cubes to fill it up. Surface area is 2-dimensional, and it takes squares to fill up the area. So let's take a look at some of these. All right, first one we're going to look at is a cube. Now, with a cube, you are going to take all of these sides, and you need to understand that if that's 3 inches, all of them are 3 inches. Your formula for volume is going to be capital B times H. Now, this can change for a cube. A cube volume can also be S cubed because you're saying side times side times side, which is S cubed. All right, so I want to look at this one, though, our formula capital B times H, because we're going to talk about some triangular pyramids and prisms and things before long, but even in other grades, that capital B can be broken down with different base shapes. So here, our base shape is a square. So this is where we would say S squared times the height, which in this case, your height would be the same thing as your S, so that's when we have S cubed. So we have S cubed, which would be a 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So our volume here is 27 inches cubed, because again, we are filling this up with cubes, okay? We're filling it up with 3-dimensional shapes. That's how you fill up a shape. Now, the next one we're going to look at is a rectangular prism. All right, so with a rectangular prism, it's a little different. This is where our capital B comes in. So capital B, V equals capital B times H. Capital B is the area of our base. Our base shape here is a rectangle. We have a 2 by 4. So a length times width. So your capital B breaks down here to length times width. This is area of a rectangle. Then times the height. So this is their length times width times height that we knew from 5th grade. So again, the capital B breaks down into length times width, and then we multiply by the height of the prism. So our base here is a 2 by 4, and then the height is 3. The height is from one base to the next base. So our height is 3. Well, 2 times 4 is 8, and then 8 times 3 is 24. So it's 24 inches cubed, because again, we fill up our 3D shape with cubes. So make sure that you understand, if you are having a volume problem, it's going to be units cubed, where surface area and area in general was units squared.